Hello everyone, welcome to my review of the AMC10A paper from 2023, which at the time of this recording and at the time that this video is published would probably be about 24 to 48 hours after most of you have taken the AMC10A paper. Now, as you can see on the thumbnail, I've called this an easy hard paper or a hard easy paper because that really depends on what your targets are. Now, this is from the MAA website. I strongly suspect it might have been an accident, but it was reviewed. These were the statistics as of about the first 24 hours after the AMC10A took place. It shows that the DHR at that point was 135. It shows that distinction is 109.5. AIME cutoffs obviously are hard to say because the exact percentage is not for certain. Now, this is very high, but it doesn't really square with what I heard from plenty of my students, which is that this was not such an easy paper. And the reason, I guess, is to start off our review is to just highlight that the front part was a bit oddly time consuming, and the back part was actually not as hard as usual, which means that if you never got to the last 8 or 9 questions, this would be a normal or even maybe a bit harder than usual paper. If you were aiming for the DHR and you went through the entire paper, you would find that the back half was much easier than you expected. So it really is going to depend on your target. Now, before I start going through the questions, just a quick remark that I'm doing this video not from my usual setup. So if the audio sounds a little bit more echoey than usual, just bear with it for the purpose of a rapid release. I think the discussion was just opened up not too long ago, so this is about as soon as I can record and release this video. So I'm going to go through the questions as per normal, and hopefully you can see this already, but hopefully we do go through this in about an hour 15, just like the actual AMC10. Okay, question 1. And in fact, the first 5 questions or so are pretty similar or almost exactly the same as the AMC12A. There was quite a lot of overlap in the front half this time. So question 1, 45 miles apart, Alicia lives in A and Beth lives in B. And Alicia is going at 18 miles per hour. Beth is going at 12 miles per hour and they meet. Now, because they meet and 18 and 12 are their speeds, the ratio is 3:2, which means that this is 3:2, and therefore the 45 would have been split into 27 and 18. So that would be option E. Question 2. Now, this sounds like a simultaneous equations question about pizza and orange slices, but then shortly after they just tell you how much does the cup of orange slices weigh. So that means that if we compare the two weights, the difference here is 3 cups. So that's 3/4 of a pound. Now, 3/4 of a pound is apparently equal to the difference in the pizza, which is 3/4 minus 1/3 is 5/12 of pizza. So 5/12 of your pizza is 3/4 of a pound. And so your answer would be 12/5 times 3/4, which is 9/5, which is 1 4/5. Question 3. How many positive perfect squares less than 2023 are divisible by 5? Now, a square that is divisible by 5 is just a multiple of 5 squared. So you just have 5 squared, 10 squared, 15 squared, and so on. Now, you should probably be aware of 45 squared being 2025. So that tells you don't stop at 45, you have to stop at 40. This is all that you get. And 40 divided by 5 means there are 8 such squares. Question 4. A quadrilateral has all integer side lengths, a perimeter of 26, and one side of length 4. What is the greatest possible length of one side of this quadrilateral? So, in this case, it's always about the triangle inequality. Of course, triangle inequality applies to quadrilaterals as well, which is that the longer side will be less than the sum of the other three sides, which means the longer side has to be less than half the perimeter. So if it's less than 13, then it means that the most you can have is 12, which, what does the side of length 4 have to do with anything? Frankly, not much at all. It doesn't have anything to do with it because there is nothing wrong with, let's say, the rest of it is summing to 10. No issue there. Let's say we go 4, 5, 5. No issue at all. So it doesn't ask you how many ways, it just asks for the greatest possible. So occasionally we do get redundant information. Worry about redundant information if you can't solve the question, or if you want to check, just make sure that you have already satisfied it. But if it looks like it didn't give you anything, that does not mean you are wrong. Question 5. What happened to my question number 5? The question number has disappeared. Well, this is question 5. Digits in this base 10 representation, we can just write this as powers of 2 and 5, because 2's and 5's gives you 10, and 10 gives you zeros at the back, and zeros at the back are easy to deal with. So this is 2 to the 15, this is 5 to the 15, so altogether when you multiply you get 10 to the 15, and so all you need to do is calculate 3 to the power of 5, which is 243, and then it has 15 zeros. 15 zeros at the back of 243 is 18 digits. This is question 5, in case any of you are bothered by the mysteriously disappeared question number. Question 6. An integer is assigned to each vertex of a cube. The value of an edge is defined to be the sum of the values of the two vertices it touches. The value of a face is defined to be the sum of the values of the 4 edges surrounding it. The value of the cube is defined as the sum of the values of its 6 faces. Suppose the sum of the integers assigned to the vertices is 21. What is the value of the cube? Now, there are two ways to do this. The intended way, presumably, is to just look at the contribution of each vertex. Now, let's say if I look at this vertex, it contributes in 3 directions. So the value would contribute 3 times. And now both of these contribute to that face, both of these contribute to this face, both of these contribute to this face. So then after that, that contributes to the value of the cube. So each vertex therefore contributes 6 times to the total of the cube. So based on that, your answer is 6 times 21 is 126. Now this would be, I believe, what is intended. You could also have taken the easy way out because it just says an integer. So you could have taken the easy way out and literally just said that, you know what, let's assume everything is 0 and that this vertex is 21. In which case, the edges would literally be 21 each and everywhere else is 0. The faces would be 42 each and everything else is 0, and you would still get the answer D as well from 42 times 3. So remember that if the question doesn't specify, you can make assumptions. In an AMC, it will be guaranteed there can only be one correct answer. If they say what is the value, instead of asking you what is the smallest, what is the largest, or how many values are there. Question 7. Roll a standard die 4 times, keep track of a running total. What's the probability that at some point her running total will equal 3? This is question 7, which indicates it's not meant to be a very complicated probability question. So with that as your instinct, you should probably consider that the numbers are special, and 3 is a very small total. So it could have come from, well, 3. It could have come from 2, 1, could have come from 1, 2, or 1, 1, 1. Now, the dash just means that anything that comes after Does not matter because you have already satisfied the running total being 3 at some point. Take note also that these do not overlap, meaning that I'm not overcounting any of these scenarios because they are all separate from each other. So I just say that starting for 3, 1/6, starting with a 2 and a 1 is 1/6 times 1/6 is 1 over 36. Likewise for this, and 111 is 1/6 cubed, which is 1 over 216. So add up all this stuff, and you would end up with a total of 1 plus 6 plus 6 plus 36 over 216 is 49 over 216. Question 8. The Bredes scale is a linear function. So linear function just means that it is a one-to-one like scaling, just like Celsius to Fahrenheit. So 110 and 350 correspond to 0. Let's use degree B for Bredes. I assume that Barb doesn't mind degree B. Degrees Barb, maybe. So 200 is going to be, well, somewhere here. The gap here is 90, 150, which means that it's in the ratio 3:5. So 3:5 means that this would be 3/8 of the way to 100, which is 37.5 degrees Bredes or Barb. Now, question 9. This is the first time sync that is a question that you should probably skip unless you straight away know how to list, because each digit appears an even number of times in the 8-digit display for that date, and we are told that it's 2023 is the year. So it's 2023 month, day. Although day and month doesn't matter, so Americans, Singaporeans, Brits can all agree that the answer does not change regardless of your date conventions. Now, to appear an even number of times, 2 is not an issue. The issue is the 0 and the 3. The 0 and the 3 have to at least appear one more time in order to balance things out. So, how will we do this? I can just decide where does the 0 and 3 go. So I will just try different cases. First of all, if 03 appears here, meaning the month of March. Now, 0311, 0322. There is no 33rd of March. Next case, I'll leave the 0 here, but I will put the 3 down here. Then I can do this, which is going to be 31st of January. That seems to be okay. And that's also the only choice because I have no 32nd of any month. If I put the 3 here, then again 13th of March, 23rd of February is fine. So that's all the cases where 0 goes in the first place. Then now I put 0 here, and there's no 30th month. So if I put this, that looks like it's the 31st of October, which is not too long ago as of this video. So it is more certainly a valid date. There are 31 days in October. It's Halloween. If we put the 3 here, this also works. And if we now put the 0 and 3 behind, you have got the 3rd of November, and you have got the 30th of November. And at least the one kind deed that the MA has done is that they have made 9 the largest option. So I've got 9 valid dates sitting down here. I know that there is no chance that I've missed anything because these are all actual valid dates, and 9 is the largest option. So that is a bit reassuring. Question 10. Now, anything to do with mean, which is just your usual average, is something that you can just write the equation in terms of the number of scores as well as the sum of scores. So if let's say that the current average is, let's say, x, and the number of quizzes is n. That means that the total is nx. Now, the first scenario, which is a single 11 on the next quiz, average increased by 1, number of quizzes, of course, increases by 1, total increases by 11. Now, 3 11s, average increased by 2, on 3 quizzes, the total, of course, increased by 33. So we have just got ourselves 2 equations to write down. So if we expand this out, you get a nice cancellation of your nx, and so this is just x plus n equals to 10. If I expand out the second one, again cancel out, 3x plus 2n equals to 27. Okay, so I subtract 2 times of the first equation from the second one, and that would give me x equals to 7 and n equals to 3, just to double check. But the one that I want is the current mean, which is x. So the answer is 7. So far, so good, I think. This is a relatively normal looking first 10. Now, I wouldn't say it's an easy first 10. It's just a normal first 10. Now, question 11. Sorry for the poor diagram. This is just from a screenshot of the paper. 11 is probably the first one that is a little bit more involved. You have got a square of area 2 inscribed in a square of area 3, and then you want the ratio of the shorter leg to the longer leg. You can do this in a bunch of different ways. What I would do is to just write down 2 equations, because these are 4 congruent triangles, right? So I can say x plus y is equal to area 3, so square root 3. Now, by Pythagoras, this is square root x squared plus y squared, and so the area is x squared plus y squared equals to 2. Now, basically what you need to do is to find the ratio of the 2 legs. Now, a third option you could have used is just to say that the area of each of these is 1/4. Okay, I shouldn't write it there. The area of each of these small ones is 1/4, so half xy is 1/4, xy is half. Now, you basically just need 2 out of these 3 equations, because any 2 of them could give you the third. So it's just make sure you have 2 of them, and then from whichever 2 you got, we want to solve for x and y. I think that I will. You know what? I think the easier way is just to use the 2 equations 2 and 3, since I have all 3 of them written down, because this is 1. So that's convenient, because okay, obviously it's not x minus y is 1, it's y minus x is 1. X minus y is negative 1 by the choice of my labeling. So y minus x is 1. And x plus y is square root 3. So if I sum and divide by 2, y is 1 plus root 3 over 2. I subtract and divide by 2, x is root 3 minus 1 divided by 2. So shorter leg to longer leg means x over y. If I look at the options, I can be fairly certain it's C, right? Because that's the only one that involves square root 3. But just to be safe, let's use the usual multiplying by the conjugate or something thereabouts to just check that we have not messed anything up. So the bottom is a difference of squares. It's over 2. The top is 3 minus 2 root 3 plus 1. So answer is 2 minus square root 3, which indeed is what we expected. Option C. I'm not sure this is the best approach. So if anyone has a better suggestion for this, do that. This is the first thing that came to mind, because it felt like we have enough equations, and so let's just solve it directly. But of course, there may be a direct solution which I am not aware of. Feel free to share it, and anything else in the comments below. Question 12. How many 3-digit positive integers n satisfy the following properties? The number n is divisible by 7, and the number formed by reversing the digits of n is divisible by 5. That is a little bit boring sounding. It's a bit boring sounding because it is simply just the number formed by reversing the digits is divisible by 5 means that if your n is ABC, your reverse CBA is supposed to be divisible by 5. Now it's a 3-digit number, so A is not 0, so that just means A is 5. And so the number is now divisible by 5 when you reverse it. The only thing you need to do is just to count multiples of 7, which you just need to take 500 divided by 7, get a remainder of 3, which means that the first multiple would be another 4 more, 504. And we can go on until the biggest one, which again you either divide 600 by 7 or you just keep adding 7. The largest one is 595. And in here, you will find that there are 14 of them. Now, there are a number of you who may wonder whether 560 is considered. My opinion is yes, it should be considered because when you reverse it, 065 is not a 3-digit number, but it's still a number. Nonetheless, I'm aware that some of you disagree. Whether the MAA agrees to accept the answer 13 will be left to their auspices, and I think for now we will just assume that it is a number. It's not a 3-digit number, but it is a number, so my answer would be 40. Option B. Okay, question 13. Again, not such a straightforward mid-range question, because for the AMC10, remember that trigonometry is not expected. So if you use trigonometry, then this is not very hard, but I'm going to explain how we can do it without trigonometry. So A and C, Abdul and Chiang, are standing 48 feet apart in a field. Bharat is standing in the same field as far from Abdul as possible so that the angle formed is 60 degrees. Now, very naturally, I think of an equilateral triangle. That's not the furthest possible, right? But that certainly would be a starting point. And I know that I can go further. So for example, I could then say maybe I come here. This is a bit further, then this is a bit further. So how far do I want it to be? And or rather, where do I want to Bharat to be so that he is as far as possible from Abdul? Now the answer just comes from fancy you're saying is that recognizing what is the loci that is being described. What's the locus that is being described, which is basically a circle. Well, not the full circle technically, just the major arc, but I'll just draw the full circle because it tells us what's going on, which is basically that by your angles in the same segment, anything here would be the same angle. So if you want this distance to be as long as possible, you would just want the longest possible chord of this circle, which is the diameter. That's the longest one. And the diameter would give you a 90 degrees here. So this would be a 30, 60, 90 triangle. And a 30, 60, 90 triangle, personally, I don't consider 30, 60, 90 to be trigonometry. And I think the AMC10 also does not consider it to be trigonometry, which is why full-fledged trigo is not included, but this sort of quote-unquote trigonometry or special triangles is included. So you should know the ratios are 1 root 3 to 2, which means that this is 2 over root 3 times of 48, which is 32 square root 3. You're supposed to square this, so your answer is just 32 root 3 squared is 1024 times 3 is 3072, and that would be option C. Question 14. A number is chosen at random from among the first 100 positive integers, and a positive integer divisor of that number is then chosen at random. What is the probability that the chosen divisor is divisible by 11? I got a shock when I first saw this because I was thinking that it was a random divisor is chosen. Isn't that just counting multiples of 11? Then, of course, I realized that, oh no, you choose a number and then you choose a divisor of the number. So, there are not that many multiples of 11, means that your chances are even lower than 9 out of 100, since you have got to first select a multiple of 11 and then select one of its divisors. So it means that you have got to pick one of these numbers, and then from that number, you have to pick a factor that is also still divisible by 11. So for example, if this has two choices, 1 and 11, so that means that you have got a half chance of picking 11. This one, the divisors are as such. So you've got 2 out of 4, which is half as well. This is 1, 3, 11, 33, and 2 of them are, hang on a second, that's always half, isn't it? Now, you could have listed everything just to be sure. Here I can tell you that it is true that for these numbers, which is 11 times k, where k is at most 9, exactly half of the divisors would be multiples of 11, because basically for every factor, you have got a factor d and 11d. And the small ones and the big ones are basically going to be split like that. So if you have a factor that is not 11, then 11d would be the corresponding factor that is a multiple of 11. So half of them would always be divisors of 11, which means that there is a 9 in 100 chance that you at least get one of these first, and then a half chance that from one of these you get exactly the desired, which is one of the multiples of 11 among the list of factors of that number. So answer is just 9 over 200, which is option B. Okay, question 15. We have got an even number of circles are nested. I feel like this is not a new problem. I can't remember where I've seen it, but I feel like the AMC8, the AMC10 have given this configuration before. The radius are just increasing by 1, so the radii are just increasing by 1, and we are looking at how many circles you need for the shaded area to be at least 2023 pi. Now, each of these, I want to say crescent moons, they don't really look like crescent moons, but each of these are just going to be quite nice. In terms of area, it's just 2 squared minus 1 squared, 4 squared minus 3 squared, 6 squared minus 5 squared, and so on. So it's 3 pi, 7 pi, 11 pi, and so on. And the pattern, which is very easy to confirm, is that they just increase by 4 each time. So my initial question is 3 plus 7 plus 11 plus how much is going to then give you at least 2023. And of course, these are multiples of 4 minus 1, so I will just write 4n minus 1. I will also note that each of these terms come from a pair of circles. So the first one, where n is 1, needs 2 circles. Then 3 plus 7 needs 4 circles, so actually this is 2n circles in order to get this. So let's just add it up. There are n terms here. The average is 4n minus 1 plus 3 over 2 is 2n plus 1. So n times 2n plus 1 should be more than 2023. This is integers, so you don't solve a quadratic inequality, you just estimate, right? And my first estimate is that since this is a bit more than 2n squared, I'll use 30. 30 times 61 is too small, which means that 60 is too little, and so it should be 64. If you confirm and you try n equals to 32, 32 times 65 is going to be equal to 2080. So that is indeed more than 2023. So that confirms that the answer is E. Let's continue. Now, at this point, this is about the first 15 questions. This is a normal-ish 15 questions, I would say. The back half is where the difficulty does not spike as much as we expect it to. Not that they're super straightforward, but that it seems like we have got 10 questions that all look like they are of like comparable difficulty. It doesn't have a noticeable jump. That's what my sense is. So it is possible that all these questions are just a bit too hard for some of you. But just a bit too hard as compared to being a lot harder is a different difficulty, even if you didn't actually feel it. Okay, so question 16. Table tennis tournament. Every participant played every other participant exactly once. This is a usual round robin. There were twice as many right-handed players as left-handed. The number of games won by left-handed players was 40% more. So more right-handers, but more games won by left-handed players. You can actually use some tricks with answer options here. So I'll lead with that first. Tricks with the answer options. Games won by left-handed players is 40% more than games won by right-handed players. So right-handed players and left-handed players. Yeah, for baseball fans, this looks like right-handed pitcher. This is not baseball. This is table tennis. If we call this 5n and 7n, where n must be an integer, that means that the number of games has to be a multiple of 12, which eliminates 3 options. And the every participant played every other participant exactly once means that if there are m participants, then there would be m choose 2 games, right? Which is this. Or if some of you recognize this, you prefer to write it as just 1 plus 2 plus 3 until n minus 1. Either way, you would see that this is actually 9 times 8 over 2, but 48 is just not this. So by elimination, you could say the answer is B without actually even using the twice as many right-handed players as left-handed players. Now, I'll leave the details of the full calculation to you. In the AMC, you don't need to worry, but just to highlight why this is actually a unique answer and not just based on the answer options, is that if you have 9 players, and let's say there are 6 right-handed and 3 right-handed players, and there were 12 times n games, means n is 3. So they won 15 games, and these won 21 games. Now, as it is, 6 choose 2, which is the number of games among the right-handed players, they are going to win games that they play against themselves, right? That is literally a guarantee. If you're playing among your own group, someone wins. So 15 games is the absolute minimum because they play 15 games. And so this gives you an idea that, okay, if there are lots of players, then the number of games that they will play among themselves already will exceed this amount, such that it is impossible. So that's the idea, although I will leave you to work out the algebraic details as to why specifically 9 is the limit. Okay, question 17. This is a rectangle that's almost a square. 30, 28, P and Q lie on BC and CD respectively, such that all the sides of ABP, PCQ, and QDA have integer lengths. So I don't know what these lengths are. This is probably horrendously not to scale. but I can't help it, right? It just says integer length. So what can I do? What's the perimeter of APQ? Now, so it basically just says that every line that I've drawn in here, including the fact that CD and BC are split into two, everything is a whole numbered length. Now, this is a case where I think you have got the list of Pythagorean triples handy. Having the list of Pythagorean triples handy mentally, that is not on paper, but mentally, is going to be immensely useful because integer length means that they are just Pythagorean triples scaled up or literally as they are. So the small ones are 3, 4, 5, 5, 12, 13, 8, 15, 17, and you have got 7, 24, 25, and of course I don't really need to go with anything beyond 28 and 30, so I can pretty much stick to these as the so-called small ones. Bad news, none of them include 28 or 30. Good news is that you can scale them up and just test it out. So which of these are factors of 30? I see a few. There's 3, there's 5, there is 15. Now, of course, 30 is not the hypotenuse, so it's not this one. 30, 40, 50, 40 is too big, so not this one. 5, 12, 13, that would be humongously big. There will be 30, 72, so that's not it. But 8, 15, 17 looks like it can work. So that would be 30, 16, 34. Told you it's not to scale because 16 is much shorter than 12 based on my drawing. Never mind. We can do the same with the 28. And for the 28, 7 times 4 again is too big. The only other factor is 4. So I can do times 7, 21, 28, 35. That leaves me with 9. Oh, that's nice. 9, 12, 15 just works perfectly. So if you're familiar with the small Pythagorean triples, that gives you your answer immediately. Now, a quick word for those of you who are not familiar with your Pythagorean triples. What is the alternative? Let me just use, let's say, 28. You know what? Let me use just 30 as an option, right? Because 3, 4, 5 is simple. How do I, let's say, deal with 30 if I didn't know it? Now, the answer is that if you didn't know, then just write 30 squared plus x squared equals to y squared. And that means that if you factorize using a difference of squares, y plus x, y minus x should be equal to 900, and x has to be small. X has to be less than 28. So you need to look for two close factors of 900. And if you look for close factors of 900, something like, let's say, use 10 and 90, that will still be not close enough. Right? You will need to go closer. And at some point, if you just got closer and closer, 18 and 50 would pop out. So if 18 and 50 popped out, that would give you y is 34 and x is 16. So there is a way to do it if you did not know the Pythagorean triples offhand. But when numbers are small, I would probably just count on it has to be just a scaled up version of one of the small ones. So that would be how I would have done it in the contest conditions. Okay, question 18. The first of two big polyhedra that are meant to scare everyone. This is a rhombic dodecahedron. Now, to be honest, I did not know what a rhombic dodecahedron is, and you do not need to know either, because they tell you. They tell you that there are 12 faces, and each of them is a rhombus, and they are all congruent. So, what does this mean? First thing is that 12 faces means that there are 12 times 4, so the number of edges, each of them has 4, but each edge lies on two faces. So there are 24 edges. Now, how about vertices? Well, we have got the rather famous Euler's formula for polyhedra. I know Euler's a very brilliant guy. He has a theorem for everything and a formula for everything. Here we are talking about the v plus f minus e equals to 2 Euler's formula, where v is the number of vertices. So substituting in would give you v is 14. There are 14 vertices. Now I need to know the total first in order to even be able to talk about how many of them meet with 3 edges. Okay, so again, using the same idea as before, I can say that there are 24 edges. Each edge has 2 vertices. So there are so-called 48 vertices in the sense of the vertices being seen by edges. More precisely, you could say that there are 48 vertex edge pairs. Where the vertex lies on the edge. So I want to know the number of vertices in which exactly 3 edges meet, and I'm told that they are all either 3 or 4. Thank goodness for them telling me this, otherwise I really cannot visualize or even imagine what's a rhombic dodecahedron. So given this information, I can say that, well, 14 vertices, some 3, some 4, means that if 14 times 4 would be 56, here I've got 48, so that means that there were 8 of them which have got exactly 3 edges meeting. So the answer would be D. Right? 8 times 3. And the other 6 vertices would have 4. That would give you the 48 pairs that we mentioned down there. Please do not try to draw this rhombic dodecahedron. No matter how good your artwork is, that drawing, if you can draw it, means you have already solved the question. Right? You already know how many vertices are like that. Okay. Question 19. The line segment from 1, 2 to 3, 3 can be transformed to the line segment from 3, 1 to 4, 3. Basically, you want to find the center of this rotation. We know that there will be a rotation possible, but how do I find it? The key is not to think about the rotation actually. A tip that I always give when it comes to AMC questions is to ask yourself, why is this question simple? So this sounds like it's asking for something very complicated, but it's really not. Now, we cannot take the intersection. That does not work because it's not guaranteed that they're the same distance. Speaking of same distance, because there's no scaling involved, when you do a rotation, that does not change lengths. So wherever my P is, it needs to be somewhere where the distance to A and A prime must be the same. Sorry, I butchered the diagram. The distance to A and A prime must be the same. And the distance to B and B prime must also be the same. Now, of course, we are not going to do this in the way I've drawn. We are going to just find the perpendicular bisectors. Now, this have the same y coordinate, so the perpendicular bisector is just going to be the average x coordinate. X equals to 7 over 2. So that's straightforward. The perpendicular bisector of A prime just has to be done in a normal way. The gradient of A prime, gradient or slope, depending on your preferred nomenclature. 1 minus 2 over 3 minus 1 is negative half. So the gradient of the perpendicular bisector is just 2, negative reciprocal, and it passes through the midpoint, which is 2, 1.5. So the equation y minus 1.5 equals to 2x minus 2, which can be rearranged to y equals to 2x minus 2.5. So just put it in. Sorry for the mix of decimals and fractions. This is very bad practice. But it means that your intersection of these two is the easiest intersection ever. ST is just 7 over 2. Let's use decimals in the end. 3.5, and then 2 times 3.5 minus 2.5, 4.5. So 3.5, 4.5 is going to be the point, and the difference is 1. The fact that they can be rotated is still something that would hypothetically need to be checked, but you are told that it can be done using this point, so we do not need to worry about can it really happen. We just take our answer and move on. Okay, question 20. Every 2 by 2 square contains 1 square of each color. Now, I don't know whether you got a W for white in the question paper, right? I just know that certainly, based on what I've seen, there was actually no indication of this. So, but when I looked at it, I was like, wait, is something missing? Is there a printing error? And then by the time I typed the question, now I realized that no, it's not a printing error. It's just white, being just well, clearly white, whereas the rest of them on paper, being in grayscale, they need to indicate whether it's blue, red, or green. Now, anyway, what we can notice is that if every 2 by 2 square contains 1 square of each color, the middle square will satisfy all the 2 by 2 squares. So you've got 4 choices for which one to use that. Let's just assume that that's white, just like here. So 4 choices times something. Now, I cannot repeat it anymore. So by symmetry, I can do anything I want on top. So let's say that I have got 3 choices here. Let's also just use, I shall not write red in green, that's confusing. Let's just assume it's red. So 3 choices there. We can't cheat because all the answers are multiples of 12. But it means that they're all 12 times something small. So clearly there are not that many ways to go about doing this. So let's just test out the rest of it, right? So these two are green, blue. These two are green and blue. Now, if they are pointing in the same way, like this, then the leftover is I need another red and another green, which can be either green, red, green, or red, green, red. So there are 2 choices. If it's green, blue, green, blue. By symmetry, there will also be 2 choices if it's blue, green, blue, green. So we now have to just check, what about if it's the reverse? And very quickly we realize that, oh, if it's the reverse, this must be red because it cannot be any of the other 3. So there would just be 1 choice. And then again, if you reverse them, it would be just 1 more choice. So 12 times 6 is 72. Question 21. Let Px be the unique polynomial. You know what? I don't really feel like reading this out loud. I don't feel like reading this out loud. It's not that complicated anyway. It's very, very, I might even say, contrived. Root just means when you substitute, you get 0, right? So 2 is a root of Px minus 2, means that P0 is 0. This means P9 is 0. This means that 4P4 is 0, so P4 is 0. This means P1 is 1. Okay, so that's not the same as the others. Now it says minimal degree, so you don't want to have too many unnecessary roots. And they tell you that they are integers with 1 exception. So what are the roots? Well, I already have been given x minus 0, x minus 9, x minus 4. That would not satisfy P1 is 1. So leading coefficient 1 means that I cannot just multiply a constant in. So I need another x minus r, where r is that fourth non-integer root. Quick substitution. Tells you that 1 minus r is 1 over 24, r is 23 over 24, and so 23 plus 24 is 47. Yeah, now this begins the final 5, which are not nearly as hard as I don't want to say should, because AMCs have varied in difficulty over the years, but not nearly as difficult as the last 2 or 3 years, and not nearly as difficult as you would expect, is probably a fair way to put it. Okay, question 22. Now, this looks scary, and then I promptly realized the moment I actually got to sit down and draw something on it, it's not very hard. I say it's not very hard because the key to understanding things about tangent circles is to ignore the circles and focus on the centers. If two circles are externally tangent, it just means that the distance is the sum of the radii. If two circles are internally tangent, it just means that this length here is the difference of their radii. So by using that and ignoring the fact that this is a very distracting diagram, we get away with just focusing on the centers. So circle C1 and C2, the big ones, have radius 1, and the centers are these two. They are 1/2 apart. So notice that if I extend this out, this is also half and this is also half, because this is a radius of C2 and this is a radius of C1. Now that happens to also be the diameter of C3, so that means that C3 has radius 3/2 over 2, which is 3/4. Now C4 is the confusing one. At first I thought they were just circling C4, and then I realized that no, the circle is that tiny. So the center is somewhere here. And what we don't want to do is to get too distracted by all the information. I'll just call the radius r and use the tangencies in the way I mentioned. Firstly, it means that the distance to the center of C3 is the sum of radii. Secondly, it just means that the distance to the center of C2 or C1 is the difference of their radii. So that triangle with green dotted line, red dotted line, and solid line, the solid line is 1/4, the red dotted line is 3/4 plus r, and the green dotted line is 1 minus r. And that is it. Just use Pythagoras to find r. Not too hard, I think. Cancel r squared. So 702r is equal to 3/8, and so r equals to 3 over 28. For those of you seasoned with the AMCs, you know that there are a lot of tangent circle questions that always show up. So this is a useful tool to be consciously aware of. Just sum of radii and difference of radii. We do not need to compute everything in full. #23. Now they call complementary divisors, but it just says if the positive integer C has positive integer divisors A and B with C equals to AB, then AB. Basically, if just A times B equals to C, we call them complementary. Very unnecessary term. Suppose n is, I think I typed missing article, it's probably a here. A positive integer that has one complementary pair of divisors differ by 20 and another pair that differ by 23. What's the sum of the digits of n? Now this is kind of one observation kind of question. And the one observation is simply that a few questions ago I mentioned this. Why is this question easy? The answer is because this is not difficult to solve because it's difficult to satisfy. Now, difficult to satisfy is more information giving because it's so rare. Now, the idea is that let's say my two numbers differ by 20 and these two multiply to n. Now, where would the two numbers that differ by 23 be? Now, if let's say that you took this one and multiplied them together where these two are the same, this obviously is bigger than n. So it can't be there. Now, if you slide it to the left by 1, sorry, it's not by 1, if you slide it to the left down here, this is too small. So essentially, you have just got two choices, and I'm just going to call this by symmetry. Let's use x minus 10, x plus 10. We are saying that it's either x minus 12 times x plus 11 or x minus 11 times x plus 12, right? That's the only ones that are not clearly smaller. But since x minus 11, x plus 11 is less than x minus 10, x plus 10, it means that you need to increase from this in order to get the same product. So this is also wrong. This is smaller than something that's already smaller. So it just simply confirms that this is your pair of equal things. And solving it just gives you x is 32. And so n is 32 squared minus 100 is equal to 924. Answer is 15. Now, don't get me wrong, these are still good quality questions. They are quite creative. I like them. I just feel that position-wise, it is not at the level of a traditional question 23. Okay, 24. And again, sorry for the potato quality diagram. Didn't have time to make a nicer one, but it doesn't actually matter that much. We have got 6 hexagons, and we want to find what is the area inside not occupied by the blocks. Now, you want the area not occupied by the blocks. That means that we are trying to find out basically the area of the big hexagon, which basically means we need the length for the big hexagon because the lengths of the small hexagons are just 1. That's already given as well. Now, first of all, there is a way that we can very reasonably guess, which is that if we were to slide everything, because they're all 3 sevens, by symmetry, because it says from any corner of the frame to the nearest vertex. So if we were to slide everything, one could imagine that in the final result, which I am not sure if I can draw it well enough, you suspect that it may look something like, let me see if I can at least draw 1 or 2 corners of it. You suspect that they would just land like this. Now, of course, when I draw this, my drawing is very far from being nice, but if this were true, it means that everything is an equilateral triangle. The side length would be 3. And if that's the case, of course, we could solve it. Now, you're going to find that that is actually the side length. I'm going to explain a bit more carefully why that's the case, because my very, very, very low quality drawing is not going to convince anybody. So remember that everything's regular. So everything here that you see that looks vertical is vertical. They're all parallel. Everything that looks that they're diagonal in this direction, they're all parallel, and same for the other way. So I will just try to draw something down here. This bit is a parallelogram. So this here is 1 as well. This is 1. This is 3 sevenths. So the question is, what is that length down here? Now I claim that if we were to extend this out here, now this has all 60-degree angles, so this is obviously equilateral. So this length here is also 1. This is also 1. And this tiny bit, this red length here, is 3/7. So your length is 1 plus 1 minus 3/7 plus 1, then plus back 3/7. So it's really just 3. So that's the length of your big hexagons. And so the question becomes just finding the area of a regular hexagon, which is just the area of an equilateral triangle times 6. So the area of an equilateral triangle of side length x, remember that by your 30, 60, 90 triangle, this is x over 2, this is root 3 over 2x. So the area is half times x times root 3 over 2x is root 3 over 4x squared. This is the area of an equilateral triangle. So area of the large hexagon is 6 of the length 3 equilateral triangles. Then you subtract off 6 smaller hexagons, and each of them has 6 smaller equilateral triangles of length 1. So we just do a little bit of computations, and this would give you 9 over 2 square root 3. This is option C. Finally, question 25. Oh, this is actually quite a bit faster than I anticipated. True to the fact that the back end does not take the usual length of time. If you are having headaches with visualizing icosahedra, I would like to highlight that on the actual paper, as well as on the screen right now, you have an icosahedron. It's the MAA logo, right? This is the actual icosahedron. And it's good enough just to give you the bit of it that you need to pay attention to. You don't really need a hugely vivid picture of an icosahedron to solve this question. Okay, so the question says that the distance is the number of edges you need to travel between two vertices. So connected ones have distance 1. If they have to go via another, then distance is 2. So what's the probability that if I pick 3 random vertices, QR is more than RS? First things first, just like the earlier one, the MA doubled up a little bit. You need probably to know the number of vertices again. So same story, faces, there are 20 of them, edges 20 times 3 over 2, there are 30 of them, vertices, remember V plus F minus E equals to 2. So same reasoning gives you vertices, there are 12 of them. Now I found this to be momentarily surprising because without looking at the MA logo, I was a bit surprised that, and I forgot how a icosahedron or a 20-sided die looked like. So I'm like, huh? Only 12 vertices? But of course, if you looked at the MA logo, you can understand why, right? Because almost all of the vertices are already in view, so it kind of makes sense. Now, if you knew the number of vertices already, then that would be extremely useful. Now, the probability that a distance is more than the other distance, R, is repeated. So it's basically how's the likelihood that Q is further than S? Well, it's the same as Q is less than S. So this is 1 minus the probability that they are equal, and then divide that by 2. So obviously, you can eliminate E because there is a non-zero chance that they are equidistant. So what I can do is, since it's symmetric, let's pick R randomly first. Right? Now, from the perspective of the so-called top vertex, let's call it R, it is connected to 5 other vertices, right? We can see that. In fact, we can also compute this because if there are 30 edges, it means that there are 60 divided by 12, which is 5 contact points each time. So that means that if we are computing this, we can say that it is going to be 5 that are 1 step away. And then, of course, we know there's one directly opposite it, and then there are sort of 5 that are directly connected to it. And we can just assume that the other 20 edges are just going between all of these down here. So basically, there are 5 of distance 1, there are 5 of distance 2, and this one's distance 3. So if there's 5 of distance 1, 5 of distance 2, and 1 of distance 3, the chance of an equal distance, you have got basically 10 over 11 of getting one of these distance 1 and 2, and then 4 out of 10 chance of getting the other one to be in that same distance. This is 7 over 22. If you made it to here, thanks very much for watching. A quick note that for the AMC10A, I will not go through a complete review. If I do have time, then what I'll do next is just to go over the questions which do not show up in the AMC10A just as a separate shorter video. So this is my opinion. Answers-wise, of course, it's been verified, but opinion on the difficulty. Let me know what you think, whether you felt that it was easy, was difficult, any comments, any concerns. And for those of you who are taking the AMC 10B or 12B in a few days, all the best to all of you. So thanks for watching and see you again soon.